Hello, everyone, and welcome to another Integration Quest MuleSoft study group. I'm your host, RJ Kessler, and we are just so glad and honored and blessed to have Tricia with us today. Tricia Hammann, she's going to be speaking on VM connectors, and I've seen a lot of what she's put together, and she's done a great job. I'm really excited to be here and learning with everybody today. And so just thank you so much for being here with us. We really appreciate it. And we're all going to be learning together. And as we always do, just, ask your questions as we go. I'm going to go over a couple things and cover the usual things. Everybody's been doing great with the Integration Quest Code of Conduct. Thank you so much for following it. Everybody's been doing what their mom and dad would or should have taught them to do. So we're going to keep that great track record going. Thank you for that. I've also got to share this. It just comes up every now and then where somebody is watching one of these videos and saying, wow, these are great. Are there any more? The answer is yes, there is. If you go to these links, if you haven't already, please subscribe. So that way you get a notification. Every time I put a video out, you'll get a notification of a new video. And I also take a moment to just say right here, if you ever see a video that we've done and it's like old and maybe it's outdated and you're thinking, okay, we could update this, there's new things going on, we can do that. We do that. We do special requests. So put a comment on it or reach out to me and let us know what we can do. We've done them before. We've done special requests and we'll get it up to speed. If you're working on something and you've kind of hit it like a brick wall and you just need to get it back going again, we can do a study group on whatever you would like, and just check out these videos. It's a wealth of information out there. That's why we love doing this. We love helping people. We love helping each other and learning together. That's what this is. It's a great resource and a great way to learn together. Today we have Tricia, and I always get to this page and I just kind of briefly go over everything and cover the credentials and all the expertise that she has under her belt and how long she's been doing this. She's been doing this for over 25 years, y'all. But here's the thing. It's not just the credentials and the expertise that she has. It's the fact that she's willing to come here today and give back to that. And that's what I'm super thankful for, because this is all new to me. Anybody that's talked to me before, and I've told everybody in real life and on here, that I've only been doing this for like a year, you all. So I'm learning with you all, and just what a huge thanks that I have to say, Tricia. Thank you for coming and sharing your expertise with us. So I'm going to stop talking so she can do that. You all help me give her a warm welcome, and let's turn this over and let's learn together. I'm going to watch this chat, so you all ask questions while she's going, and we can learn together. All right.
Thank you so much for this warm welcome. So I'm really excited to be here today with you all. And this is a quite magnificent way how to learn about MuleSoft. As Ajay said, everyone together, and this is making fun. And this is the reason why we are doing what we do, because we are passionate about learning and sharing. And this is the reason why I'm here today. Thank you so much for the invitation.
Absolutely.
And I will start to share my desktop. And yes, so welcome attendees of the Integration Quest Study Group session. Today, we are going to cover the topic related to VM Connector. And yes, so I will be your host for today, and I would like to clarify something up front. This is a question that I receive very often on my classes, because we are accustomed to speak about VM, and this is not so clear about what is the meaning of VM. And VM is short for virtual machine. Okay, and this is the way how MuleSoft named this connector. It is unrelated to VMware. It is not virtual messaging. Here we are speaking about asynchronous queue-based messaging. And yes, let us move forward. This is the agenda that I prepared for today. We will speak about what is messaging all about. We will go to the second point, why asynchronous messaging. Then we will cover the topic of a message broker, what is the meaning of it. And we will then go to the to two topics, what and when simple queuing. This is something that you are always reading or hearing when you are learning about the VM connector. Afterwards, we will do a comparison between VM and a message broker. And we will dive into the demos where we will see the 4 operators live. And also we will speak about the different queue types, okay? And I will do a demonstration of it. And afterwards, we will go to the wrap-up and questions session. And according to my experience, when I'm teaching the VM connector, I got some questions. They are always the same, and I just collect them together, and these are just 3 of them, so that very important one, so that you can have it in case that you are getting ready for the certification. I hope the whole content will help you to understand the meaning of the VM connectors. And let us start talking about why messaging. Why messaging? So, believe it or not, messaging is behind almost everything we experience daily. Every notification, every shipping update, payment confirmation, and getting it right for the very beginning, it makes system fast, resilient, and scalable. You can imagine like flight confirmation. Now all of us in holidays mood, and we love to travel. So this is a great example. So you are doing a flight booking, you picture a flight confirmation, and yes, so you as a customer, you don't have time to wait while the system is just sending the email, updating billing, checking your account, if you have an account, if all the details payments are available, then getting notification about the service. So you as a customer would like to have an answer and yes, and have all your data safe. So we are speaking here about fast answer, safe systems, and independent, okay? Without you as a customer having the experience of waiting, slowing down, and so on. So messaging is what lets each of these happen in a fast, safely, and independent way without one system slowing the other or one system blocking everything else, okay? Because we know that a customer do not have time to wait, a checkout shouldn't fail, just because a service is briefly down, and a system shouldn't collapse when 1,000 of orders are arriving at once, for example, in a flash sale. Then why asynchronous messaging? Because making the client wait on every downstream steps creates a very slow, fragile systems, and also, and I mentioned it, it is all about the customer experience, okay? We want our customers to be happy, to have enough time to enjoy life, and yes, to ensure that the data and the systems are working in a proper manner. And asynchronous communication, asynchronous messaging remove that dependency, okay? And yes, it lets the producer continue immediately. For example, a caller gets a fast response. There is no time that it is waiting for it. For example, in case of a failure, it does not block the execution of the whole process. Then you can, in a very natural way, absorbs every traffic spikes. So the message queue up instead of overwhelming a service. It enables also safe retries without rerunning the entire transaction. And it offers you decoupling. It decouples producer and consumer, which is allowing you to execute a scale, to execute strategies in case that something failed, or secure a deployment immediately. Then, what is a message broker? And when we are speaking about the VM connector, we are always hearing, oh yes, a message broker, this is an amazing concept. But I want you to be sure about what we are referring to when we speak about a message broker. And yes, a message broker is, just hold on, I'm not yet there. Let me just change. Okay, something is blocking me for doing this. Just give me a second. Okay, now. Yes, so a message broker. When we are speaking about a message broker, you need to be clear that a message broker is a software which is outside of our system. If we are speaking about MuleSoft, it is a software which is intermediary, and it takes a sole responsibility about receiving, storing, routing, and delivering messages, okay, between applications. And this is a dedicated infrastructure. It is external to our applications, and it communicates to it, through it, okay? So as I said, it is external, so that means it is separate from the applications using it. It offers you a very robust way to handle the messages. It supports advanced patterns, that means publish and subscribes, delivery guarantees, as for example, at least one message or exactly one message, or topic-based routing. For example, if you, we have seen in the past month, we were working about the football world championship. So you can imagine having like a message broker, which is delivering the stage of a football match. This is what we call a topic-based routing. Then a message broker, it can connect many different applications. We do not speak about just two endpoints. We speak about many different applications. And it offers the possibility to include message transformation, for example, doing filtering or advanced retread policies. And of course, it also scales independent from the application you are working with. And yes, so in our day-to-day business, and me as an instructor, I also hear people speaking about, hey, Apache Kafka, RabbitMQ, IBM MQ, ActiveMQ, and Amazon SQS and SS service. And yes, these are well-known examples of message brokers. Then, now we are clear about what is the meaning of messaging, why we are hearing always simple queuing, and we have seen what is a message broker itself. And now let us just put both of them on a scale and see their key differences, okay? And the simplest way to think about this is, and this is the most important one, if you are taking notes now, please get ready for it. The VM connector lives inside your Mule application. You don't need extra infrastructure. You don't need any setup beyond publish, consume, listener, and the queues. A message broker lives outside it. It is a separate system, and you have to deploy, you have to configure it, and you have to maintain it on its own. That different cascades into everything else. VM is a scoped to your Mule domain and scales only as far as your Mule runtime does. A broker has not such ceiling. It connects multiple applications across different technologies and scales independently for a massive concurrency. Then related to complexity follows the same pattern. VM is just when you are configured, and we will see it later on in the demos, it's just a few clicks, okay? A broker means topics and changes, permissions, clustering, okay? So here is the rule. If you are thinking about, okay, Tricia, what is the main rule here to remember? Reach for VM when you are decoupling steps inside your Mule application. It is simple, it is lightweight, you don't need any other external configuration. Reach for a broker when you are wiring together multiple systems in a complex event-driven architecture. Now, the key takeaway is indeed VM Connector is not a broker replacement. It is a light built-in option for simple messaging inside Mule. Once you're connecting different systems and need a strong delivery guarantees, that's when you bring a real broker, as we have seen already, for example, Apache Kafka, RabbitMQ, and so on. Then let us just check what simple queuing means. As I said, when you are starting reading about the VM connector, this term is going to appear very often. And when we are hearing simple queuing, I want you to remember, simple queuing is everything will happen within the same Mule application. No external systems need to read a queue. No ultra-robust delivery guarantees are required. No publish subscribe with multiple subscribers is needed. No external message broker is needed. It is just simple queuing, simple decoupling two steps within the same logical flow. When do we need simple queuing? For example, when you want to connect flows within the same application, when you need to connect applications that are sharing the same Mule domain, or when you need the content of the queue to be in memory, and with it, we speak about transient queues, or save to disk. In this case, we speak about persistent queues. Now, so far, you haven't seen any queue, but we mentioned already that when we are working with the VM connector, we work with queues as well. And yes, another need that you can cover with simple queuing is when you want queues to be available inside Mule. No external broker is needed. Now, there is an example use case that I would like to mention here, because so far it's a lot of theory, and I also know that there are, because of the quantity of knowledge, it's very difficult to know what she is speaking about. So the use case is decoupling a booking confirmation. Again, so we will work with a booking API, flights API, and it will receive a request to create a reservation. Okay, so we need to guarantee that the booking is safe into the database, and it sends a confirmation email to the passenger and a notification to the billing system. So what we are going to see here. First of all, without the VM connector, we will do all of this synchronously. What is the meaning of it? When we speak about synchronous communication, one step will be executed after the other, okay? And with it, that will mean that our client will need to wait for 3 steps to be executed before receiving a response. In this case, the database information will be saved. Afterwards, an email will be sent out, and afterwards, a billing notification will be sent out. And what would happen if some of these steps throws an error? If there is an error, then the email service will slow, or it will slow or will fail, and the entire request gets stuck. So at the end, from the consumer perspective, then yes, whether the customers will need to wait, or the customer will cancel the transaction, or the customer will say, okay, I will wait till midnight. If nothing happens, I will change the booking to another airline. So And yes, this happened even though the booking itself was saved correctly. So let us mean that the first, let us think that the first step, the database information has been saved. And yes, in case that the email system breaks or throws an error, then yes, it's a pity because the first step was ready. And from the customer perspective, so this is a very bad experience. And indeed, we need to guarantee that they are having the best experience doing the booking confirmation, okay? Now, with a VM connector, the main flow saves the booking to the database in a notification queue. Then it publishes a message to the VM queue with the booking data. Immediately, a response to the client is sent with a HTTP 200 OK, the booking is already confirmed. In a separate flow with a VM listener, it consumes the message in the background and handles the email and billing notification without the user waiting. So from the user perspective, so they are not seeing what is happening behind the scenes, but they are getting a great experience, they are getting the confirmation, they are seeing that the booking has been done and the billing notification has been received. And this is the use case, how you can improve the experience of a customer and also the safety, fast and reliability of your systems. Now, how can you work with the VM connector? And I have seen in the chat some questions related to, hey, how can I learn about MuleSoft in general? And Ryan, thank you so much. You sent the answer, start to learn about REST APIs. So what you are going to see here is going to be, for the person that raised up this question, is going to be completely new. What you are seeing here is when we are working in Anypoint Studio with the MuleSoft technology, you will need to add the VM module to your project. Why? Because the VM module is not available per default in your projects. So in the VM module, you will see indeed, so in the project itself, you will see just the HTTP and sockets modules available. And the VM module need to be added by just, let me just change the color of my pointer. The VM module need to be added in the Mule palette by clicking on Add Modules, and then you will need to drag and drop from the left to the right the VM module. And as soon as you have done this, you will be able to see the VM module added to the palette, and additionally to this, added also to your project as a dependency. And yes, the VM module will offer you four operators. The first one is consume, the listener, which we speak about it, the VM listener, and the publish operator and the publish consume operator. 4 operators, okay, in the VM module. Great. Then let us just move forward here. All right. Now, working with the MuleSoft VM modules, we have seen already the 4 operators. Let us check the behaviors, each behavior, and what are they doing? And this is what we wrote in the keynote. So first of all, the VM listener. The behavior, it triggers automatically. It triggers the flow execution where you are working with it. And very important, it is exclusive per queue with consume. Okay, exclusive per queue with consume. What is the meaning of it? In order to trigger the execution of a flow where your source is a VM listener, then you need to have another flow where the queue information has been published. Okay, so then yes, A VM listener is only working, is always actively watching a queue. And the moment a message arrives, it grabs it automatically, okay? And no one has to ask it to do it this, okay? This is the way how it works. A consume operator works exactly the opposite. And this is our next operator. It reads only when triggered. And if there is no message available in the queue that is supposed to be read, it will throw a VM queue timeout error if the queue is empty. Now, the publish operator is, from my point of view, an amazing amazing actor here, because he is indeed behaving as fire and forget, okay? It will support asynchronous communication. It will then continue with the execution of the flow, but it triggers the execution of another flow. And this is then what we will witness in our demo. It will show this asynchronous behavior, and is what we call also fire and forget. The publish consume operator, it waits for a response. It publishes and it waits for a response. It pauses flow until a response arrives, and yes, it will reply or it will time out if it is if there is no response available. Okay. So these are the key differences related to the VM operators. Now, I mentioned it already, and when we are working with VMs, we need to be also able to understand what is the responsibility of a queue, okay? So a queue can be configured when we configure a VM global element, okay? And what you are seeing under the global element properties window is the configuration window of a VM config. And what do we have? So usually we go directly to the general section, and per default, we are seeing the value being referenced. In case that you would like to be able to create the queues and to select the queue type, you need to change this configuration to edit inline. This will allow you to create the queues, to select the queue types, and to set up the max outstanding messages. And when you do this, you can configure this information seeing the queue window. And under the queue, we will have the queue name. In this case, I set up the queue name to QA. The queue type, you can select transient, which is the default value, or persistent. When we speak about transient queues, they are fast, okay? And the data is in memory. What is the meaning of it? That if the application restarts or crash, the information in the queue is lost. Now, the other type of queue that you can select here by clicking on the drop-down menu is persistent. And yes, the persistent queue type is slower, but it is reliable. Why? Because it saves the information to a disk, or it backed by the memory grid when we are working with a cluster. So then, when we speak about a cluster, the Mule runtimes and nodes can work together for a high availability. And yes, you don't want data to live on just one node memory, because if that specific node crashes, the data will disappear. When we speak about a memory grid, it solves this by replicating data across all the nodes in the cluster in memory in real time. So the same piece of data exists on more than one node simultaneously. Why is this information important when we are working with the VM connector's persistent queue? Because if a persistent queue in a cluster Mule deployment uses the memory grid, a message published to that queue is not just held by one node. It's mirrored across the application. Then there is a term that you are seeing here, and this is the max outstanding messages. And in this case, we are having 0 messages. So you can define the maximum quantity of messages that are going to be available in the queue. If this maximal quantity of message is reached and there is a message arriving to it, then this message is not going to be safe in the queue. Now, in my first screenshot, you are seeing that I set up the QA, QB to handle 10 max outstanding messages, and the QC is set to 0. If you set the queue to 0, you can handle unlimited messages. Okay, it is not that you are not going to be able to handle any message. It is, the meaning of it is that you can handle unlimited number of messages. Okay, very important. Now, after you enter all these data, you can just click on finish, and this configuration is going to appear under the list of queues that you create. So you can have several queues for any of the cases. And in my case, when we are going to execute the demos, you will see that I'm working indeed with all of these queues. Now, very important, please check with your architects, within your organization, with your colleagues, before you start building with the VM connector. Why? And this is a very important note to mention, because persistent queues are not available in CloudHub 2.0 or in Runtime Fabric, only in CloudHub 1.0, and also on-premise hybrid deployments. So therefore, it is worth to verify this against your company setup, architecture, and ensure that you can guarantee persistency while you are working with the VM connector.
That's a little bit, you can, because we have clustering, they behave in somewhat of a persistent way on CloudHub 2 and Runtime Fabric. We just lose that CloudHub persistent thing. So they do say to use Anypoint MQ if you want to stop the application and have the messages survive, right?
Yes.
But they don't, a lot of what you might be using persistent queues for works just fine on clustered queues.
Okay.
They make it sound worse than it is.
Okay, thank you, Ryan.
Yeah,
thank you so much. Because I just wanted to say that MuleSoft suggests a workaround, and this is to use the Anypoint MQ. And I don't know, Ryan, how is your experience with it, working with the Anypoint MQ?
Oh, it's good. It's just more setup, right? Because you have to go make a queue, and then you have to go make an exchange. You have to write, you have to have a different connector in your application. So for the main thing, the reason you would want to do the workaround is if you're, I had an integration where this would make sense. I didn't want to have a cluster. I just wanted one worker or a replica, right? And we had a safety queue where it was very slow retry. So whenever it would try to hit the backend system, if the system was not available, it would put it back in the queue, and the scheduler was like on a 1 hour retry, right? Because we didn't want to because it was going to send a real message to a person. So finally, so we had a queue that was down. We had a backend system that was down for weeks, right? And you could stop the application or something. So that would be a case where a clustered queue is a little bit of a risky place to save long-term data, right? So Anypoint MQ is nicer for that. And just like you said earlier on the whole message broker decision point, that's what this is. Anypoint MQ is a message broker. So they're saying if you want long-lived persistent messages, then we're not going to give that to you for free with CloudHub anymore, like they did on CloudHub 1.0. That's all they were saying. But we can still do a lot of the other things you showed are the benefits of persistent queues on CloudHub 2 and Runtime Fabric. You just have to use clustering and 2 replicas.
Perfect. Got it. Thank you so much, Ryan. Yes, this is an architect speaking from the architectural point of view. Great. Yes. Thank you. Now, we reached already our hands-on demo. And I wanted to let you know how I built up the flows. And yes, so we have in demo 01, we have a publish operator working with a listener. We configure the listener to handle requests with the method get, and the path is going to be demo. We work with a set payload transformer and VM publish operator working with QA. We then work with a VM listener, which will automatically consumes and logs the messages. For it, we work with a logger as well. In the demo 02, we work with a publish and consume operator, with a VM publish and VM consume operator. We have the HTTP listener working with a method get and the / demo consume. We work with a set payload transformer and VM publish operator, publishing messages in QB. And we build a separate flow with the VM consume operator, which will read and log the message only when it is triggered. Then in the demo 03, we work with a publish consume operator, request reply. So we build up a flow with the HTTP listener, and the path is publish to consume. We work with a VM publish consume, where we are working with the QC. And the publish consume operator will process the flow and waiting for a reply from a listener flow. And yes, if there is no information there, it will throw a VMQ timeout. Then I also include a demonstration about the transient and persistent queue. We will work with a QD instead of a QA. We will publish the message without consuming it. We will restart the application, and we will witness how the message is lost when we are working with a transient queue, which is the default value, and we will then switch the queue to persistent. We will save these modifications, and we will repeat the steps and see if the message survives after restart. Very important when you are working with the VM connector, please keep the queue names consistent across publish and consume and VM listener components, because it happens to me when I was building up this example. There has been a mismatch, and I was waiting for the consumer to consume a message, and it has never been received. And yes, so very important that you keep these queue names consistent. Yes, so here we have a demo components overview again. So demo 01, our VM feature operator is published. The key behavior is fire and forget. Demo 02, the VM feature operator is consumed. The key behavior is reads only when triggered. Demo 03, publish consume operator is going to be featured there. And we will see a key behavior process flow, waits for reply. And demo 01, we will then see the behavior of transient versus persistent queue. And yes, we will see the key behaviors if the message survives or not at restart. Now, this is what I built up for the demo 01. And I already explained more or less what you are seeing. If it is your first time seeing a configuration in MuleSoft, this is a flow. In the demo 01, we are working with two flows, the publish to QA flow and the consume QA flow, okay, these two flows. And yes, so the listener in the publish to QA flow will trigger the execution of the flow. The set payload transformer will generate a payload, a string value, how are you? The publish component will send that message to QA. And in the demo 01 consume QA flow, we work with a VM listener, which is actively watching the QA. And as soon as a message arrives, it reacts automatically. You don't need to trigger the execution of the flow manually. And the logger component will log the payload consumed from QA directly in Anypoint Studio in the console. The expected response is a 200. How are you from publish QA flow? And the logged message in the console will be, how are you, now available in QA from consume QA flow. And yes, let's see all of this in action. And for it, let me just go back to Anypoint Studio and to Advanced REST Client. So this is my project. And we will go to the demo 01 flows, publish to QA flow, and VM listener QA flow. And I will just run the project. And in the meantime, so I am working with Advanced REST client, and I will send a request to /demo because my listener in the publish to QA flow is configured to handle this request, method get, and the path is /demo. All right, I see a status deployed, and I will send the request. And yes, so we are seeing at 200, how are you, now available in QA. And if we go back to the console in Anypoint Studio, we will see demo 01, VM listener. So first of all, demo 01, publish operator. And let us see the content is, how are you, now available in QA. Okay, this information is coming from the demo 01 publish operator, publish to QA flow. And we have also information log from the second logger, which is how are you now available in QA from consume A flow. Okay, and yes, with it we have seen the demo 01 publish operator, and I would like now to stop the execution of the flow. And let me just debug the project. Let us see this in action with the debugger. All right, so I will send the request as soon as we see a status deployed. In the console, this is the case. Yes, a status deployed. Let us send the request, and we reach the set payload transformer. So let me go to next component in the debugger. We reach the publish to QA operator, publish operator, and I will just click on next. And yes, as you can see, we reach the logger VM demo flow. And I will click, so far we are seeing this blue bar moving from the left to the right. I see a request timeout because I was speaking too long. I will click on next processor. And even though we got a request timeout, we see the execution of the flow demo 01. It continues. So I will just click on next. We finished the execution of the flow. Let me send a request again, and I will go a little bit faster through the components. And we see at 200, how are you now available in QA? And the demo 01 VM listener QA flow is still being executed. And this is what we call fire and forget. So it triggers the publish operator. It triggers the execution of the VM listener QA flow. Okay. We see that it continues with the execution of the publish to QA flow, okay? And yes, what you just witnessed is what we call asynchronous communication, okay? And the publish operator is supporting asynchronous communication in the way we have seen it, okay? So then let us go back to our slides. And yes, so we reached the demo 02 publish operator, publish to QB flow. This is, again, we have two flows available. In the publish to QB flow, we are working with a listener, which is configured to work with a method get demo consume is the path. The set payload generates a string value, sending UPs and COM, and the publish operator component send that message to QB. Now, in the demo 02 consume QB flow, the listener triggers on get demo consume 1. We work with a VM consume operator, a manual on-demand read, unlike the VM listener, which reacts automatically. and it pulls from QB when this flow is explicit trigger. So when the consume QB flow is triggered. Then the logger logs the consume value from QB in the console. And the expected response is at 200 with the string value sending UPs and CAN from publish to QB flow. And the message log in the console is sending UPs and CAN from publish to QB flow from consume QB flow. All right, then let us see this in action. And for it, I will go back to Anypoint Studio. I am running already my project in with the debugger. Let me just scroll down. Yes. So here we are, demo publish operator, publish to QB flow. We are working with a publish operator and the consume QB flow. So our start here is the consume operator. So let us publish a message in QB, and afterwards triggers the execution of consume QB flow by sending a request to demo consume 1. So for it, let me just publish the message. I will trigger the execution of publish to QB flow first. I will then just move forward with the next processor. I reach the publish to QB operator. I reach the logger VM demo flow. I finish with the execution of the flow. I can see the payload, which is sending UPs and CAN from publish to QB flow with a 200. This is great. And now let us trigger the execution of the consume QB flow. I will just send the request. And yes, so we reach the logger VM demo flow. The payload is sending UPs and CAN from publish to QB flow, which is indeed the message available in QB that we just published in the last flow. And I will just click on next processor, and I see sending UPs and CAN from publish to QB flow. And if we just go to the console, we will see then the values that both loggers log in the console. Let us just, here we are, logger message processor from, let me expand this section so that you can see it better, I hope. Logger message processor sending UPs and CAN. This is the value from the QB publish to QB flow available in the consume QB flow. And this is what we wanted to see. Okay. So we just have seen the behavior of the consume operator. We have seen already the behavior of the publish operator and the VM listener as well. So let us just now go back to the presentation. And let us check what I prepared for you in demo 03. The start here is the publish consume operator, which is available in the publish consume to QC flow. Okay, so we work here with a listener configured to work with a method get, and the path is published to consume. The set payload transformer generates a string value, have a great day, from publish consume QC flow. And the next component is a logger, a publish consume component, which is sending messages to QC, and it will wait for a response, unlike the simple publish operator in demo 01 and demo 02. And the logger component will log the response received back from the listening flow. Now, we work with a demo 03 consume QC flow. We work with a VM listener, which is actively watching QC at all times. And as soon as a message arrives, the logger will log the payload received, and the set payload will then concatenate the payload with a string value, which is processed. So the expected response here is process, have a great day, from publish consume QC flow. And the log message in the console is process, have a great day, from publish consume to QC flow set up in consume QC flow. And yes, so we understand what I create. let us just see it in action. And for it, I will go back to the Anypoint Studio, and here we are. Let me just set up both views here. And yes, we will send a message to publish to consume so that we trigger the execution of this flow. Let me just send the request. Yes, so we reach the set payload transformer, which is generating a message from publish consume QC flow. And we will click on next processor. We reach the publish consume operator. Okay, so it's publishing information or a message in QC. We then click on next processor. We reach the demo 03 VM listener. And again, I'm seeing a request timeout. So let me just finish with the execution of the flow. And yes, as you can see, the logger has been reached. I will just click on next processor, and I'm not able to see any information because I got a request timeout. Let me just send the request again, and I will go a little bit faster through the flow. So I reach the VM listener QC flow, the logger setting the payload in the console, and we reach the set payload process. And as you can see, we return to the consume QC, publish consume to QC flow, okay? And we reach the logger. And if I click on next processor, we see a process have a great day from publish consume QC flow. So if I go back to the console, I will see then the values of the logger. Let me just expand the console, and yes, we see publish to consume to QC flow. We see demo 3 publish consume operator, and we can see a process have a great day from publish consume QC flow set up in QC. And yes, as you can see, unlike the publish operator, the publish consume will publish and will wait for a reply to continue with the execution of the flow. And this is the key behavior of this operator. And we have just witnessed this behavior. Now, let us just move forward with the presentation. And yes, we will then in demo 04 see the difference in the behavior of Q-types transient versus Q-type persistent. We are working here with the QD. And yes, so in order to do any modification, we need to go to the global element VM config. And in this screenshot, you are seeing that we are working with the QD. And the Q-type is persistent in this case. We will start with a transient Q-type, which is the default value, and afterwards we will come back and do the modification to select and to be able to see the behavior of the persistent Q-type. The max outstanding message is 0 because we want to have unlimited quantity of messages available. And 0 is the default value, by the way. Now, very important to remember, transient messages live in memory only. It is the fastest option, but you will see it. The messages are lost in case that the application restart or crash or gets redeployed. Persistent, the messages are serialized to disk or are in a standalone configuration or backed by a memory grid in a cluster configuration. And when to use each? This is a very common question that I receive. And yes, it depends, and Ryan already mentioned it. So it depends on how much data loss you can tolerate, okay? So you can use a transient Q-type when speed matters at most. So, and losing an in-flight message is acceptable. It short-lived internal buffering, retries, or fire and forget notifications. Use persistent when message loss is not acceptable at all. anything tied to financial transactions, order processing, audit trails, where every message must eventually be processed even after a crash or restart. Okay? And yes, so there is a term that we have seen in the some configurations here in the VM config. This is the correlation ID. The correlation ID allows you to follow a message, a Mule event, through the different architectural levels as system, process, experience, APIs. And yes, in case that you would like to monitor this kind of information, then working with the VM connector, you can use it here. So this is what you can use related to the correlation ID. Okay. All right. Then let us see this in action. And for it, I will go back to Advanced REST Client and Anypoint Studio. And let me just change the perspective to the, design perspective. And here we are. Let us check the configuration of the VM config global element. And for it, I will go to the global elements tab. And I will select the VM config component. And yes, so here we are in the global element properties window, and I can see the QD. Queue type is set to transient. In case that I would like to modify it, and we will do it later on, I need to edit this queue, and I can select here the queue type. And at the moment, we have it on transient. I will leave it like this, so there will be no modification so far. I will just click on cancel. I just wanted to show you where to go in order to change this value. And just to ensure that we are working with a transient queue type. Now, what we are going to do here, I am working with the debugger at the moment. And I will stop the project. Let us just restart the project. I will just run the project without debugging it. And I will send a request to demo queue type. And yes, here we are. So there are some questions in the chat. And so I'm ready with the client. I'm just waiting till I see a status deployed. And yes, in the first step, I want to publish a message to QD. And yes, for it, I will just send the request, demo queue type. And here we are, bye-bye from publish to QD flow, okay? In the consume QD flow, we are working with a consume QD operator, which is called consume QD. So I will then stop the project. Let us stop the project. And yes, the project has been stopped. And I will restart the project. I will run it again. And we will send a request to demo consume D to see if we can access the string value bye-bye from publish to QD flow now, okay, in the consume QD flow. Status deploy, let us send the request. And what you are witnessing here is that there is a blue bar moving from the left to the right. So the flow has been triggered and is expecting to see or to consume the data available in QD. But because we are working with a transient queue, the message is lost and we get a 408 request timeout because there is no data available in QD. Okay. Now, let us just modify the queue type I will just edit this information and let me go to QD. And I will just click on persistent. And let us click on finish. I will click on OK. And let me save this modification. And let us check the console because I restart the system. Yes, my application is just up and running. So not yet. It's coming up. And we will wait till we see a status started. Okay. And yes, I will publish a message. So I will just send the request to demo queue type. I will just publish the message. And we see bye-bye from publish to QD flow. Okay. And I will stop the application. I will stop the application. So let us wait a bit. I will run the application. I will run my project again. Because at the moment, there is a message that has been published to QD. Remember, I'm working now with a persistent queue. So I expect now, after I restart the application, to be able to access the information available in QD. And how? I will just send a request to demo consume T. And yes, this is the case. We are seeing a 200 with bye-bye from publish to QD flow. And yes, with it, we have seen live how these two different queue types behave. And I would like just to go back to the presentation. And yes, so let us just wrap up. So from theory to practice, we started with what is the meaning of a message, what are the differences between message broker VM, what is needed when we would like to work with simple queuing. We have seen the concept of simple queuing. And then we got into the demonstration where we have seen the behavior of all the four operators: VM listener, a publish operator, a publish consume operator, and a consume operator. And my invitation to you is, if one demo is stuck with you, please, just after the presentation, go and try to rebuild it from scratch, okay? And so if you would like to do it on the weekend, next week, try to rebuild it from scratch. This is the fastest way how to put in practice whatever you got from this presentation. And yes, so in my experience, there has been always some questions that stuck out with my students, okay? And I would like to let you know which are these questions. And the questions are, first one, can external brokers read a VM queue? Can messages in a VM queue be read by external message broker? And the answer is not directly. The VM connector queues are internal, as we learned already, are internal to the Mule runtime. They live inside the deployed application process and are not accessible from outside that runtime. An external system like Kafka or RabbitMQ or any other that we already have seen, they cannot connect directly to a VM queue. Only a VM listener components within the same application can read them. But very important, if we speak about reading, so you can see how many messages are available when you deploy the application. There is a tab related to queues. You can see the quantity of messages, but we are not able to read the content. So I'm not able to see bye-bye from publish to QM or so on. So you can see the components, the quantity of them within the application when it has been deployed, working with the queue tab. Yes, and this is the answer. Now, can admins see what is in a VM queue? Can an administrator access, view, or know how many messages are in a VM queue? Count and throughput, yes. Runtimes Manager offers queue tabs, which shows queue in-flight messages per queue and 24-hour throughput snapshot. Okay, so this is for Cloud Hub deployed apps only. Message content, not directly. The VM connector can iterate over pending messages from an administrator interface. Only a VM listener consume flow can extract and read the content. Now, can a persistent message be delivered twice? Does using a persistent queue guarantee its message is processed only once? No, persistent only guarantees that the message will survive after a system crash or a restart, not that it is processed exactly once. If there is a system crash in the middle of processing, before the queue can mark the message as consumed, it gets redelivered. The same message can end up processed twice. And how can you avoid this? Working with a concept which is called idempotency. Idempotent, doing it twice is as safe as doing it once. And before saving a booking, for example, you can check, has this booking ID already been saved? If yes, skip it. So even if the same message arrives twice, the outcome stays the same. And yes, so these were some of the questions that I received already. Is there any questions? And I have seen a lot of questions in the chat, and Ryan has been very actively answering it.
There has been. I want to say some of those questions though, because this is recorded and we'll put it on YouTube, and those questions aren't going to be seen on YouTube. And it's sad that somebody watching this later would miss those questions, because Sammy, those were awesome. Thank you for asking those. Thank you, Ryan, for answering those. So Tricia could keep going. She was on a roll. I didn't want to interrupt. So you were doing awesome. So I'll ask those questions and we can talk about them real quick if you'd like, Tricia. Does that sound good?
Yes. So do you want me to read it loud?
Yeah, I will. All right.
Yeah.
So Sammy, the first question that she asked, let's go up here and see the first question on Cloud Hub 1. Actually, hold on. I'm reading Ryan's question or answer. I should read Sammy's question. Okay. So Sammy asked.
No, wait. I'll read the question, and then we can let Tricia read the answer and see if she agrees with it, because
that's a good call.
It might not be right. You know?
Yeah. That's why I'm saying, yeah, we'll just talk about it. So I'm going to read the question and then we're just going to talk about it. But I'm going to guess that Ryan's right. I mean, he knows what he's doing here. All right, let's do this. Quick question. Sammy asks, on Cloud Hub with multiple workers, are transient VM queues per worker or shared? If worker 1 publishes and worker 2 listener is idle, does the message ever get picked up? So I'll stop there and I'll come to the next question after,
yes.
after
so
we talk about that.
Very important. We are working with transient VM queues. If worker 1 publish and worker 2 listener is idle, does the message ever get picked up? And we are working with multiple workers. I do believe it will have something to do with the configuration, how it is set, no? But the question is, where are you able to set this information, okay? And this is Ryan's answer. Yes, Ryan, now your turn.
No, Cloud Hub does, it's a deployment setting. So that's why she had the warning earlier about the Cloud Hub 1, Cloud Hub 2 difference. In Cloud Hub 1, there's a persistent queues. There's a checkbox when you deploy an application that you either turn on or turn off persistent queues. So if it's off, then the 2 workers just don't share any queues. So if worker 1 is published, or worker 2 will never see that. It's just in the JVM. But if it's turned on, this used to be so confusing. It takes all the VM queues out of Mule's JVM system and puts them into SQS. So even transient or persistent queues in your app, they're all just going to be shared. So even if it's a transient message, if you publish it on worker 1, worker 2 could get it. Mm-hmm. It's possible, yeah. On Cloud Hub 2, that's what I was getting at earlier with the clustering. You have to have clustering turned on, which is another checkbox, right? When you deploy, if you have it turned off, then they won't see each other at all. And if you have it turned on, like you can't control it, they're going to share messages. There's no, and we get no policy configuration, etc. And I know that relates also to what Tricia was just displaying about admin visibility, like the count of the messages and stuff like that. That's old school. That's just old. That's Cloud Hub 1 persistent messaging. So the new world, Cloud Hub 2.0, Runtime Fabric, you guys are never going to see anything about the queues in Runtime Manager. They're just invisible. You know, it's what it was. That I think that was one of those things MuleSoft decided to reduce the feature set when they went from 1 to 2.
Okay.
Yeah.
That's good. That makes sense. On the next part of that questioning, Sammy went into asking, so with max outstanding messages, was 10 on QA and 0 on QC, or I'm thinking that maybe with 10 on QA and 0 on QC, what is the back pressure behavior at the limit? Does publish block, error, or drop? And 0 means unlimited. So what's the heap risk?
Yes, when I try with the value 10, and if there is, after 10 messages has been published, if there is a new message coming up, it will not be safe. Okay, so this is the behavior. So when I set up a 0, it means unlimited. So I will not have any maximal capacity of messages getting into the queue. I don't know if from the architectural point of view, Ryan, is there a limit in the queues? Is 1,000, 2,000, or are we speaking indeed unlimited? So it's open.
However much the computer can handle, which sometimes isn't that much.
Okay. Okay. All right. And so from the architectural point of view, this back pressure behavior, how it is then being seen, Ryan? So if
I wrote this one. So this is a really fun experiment to run. You make a little application, because all you got to do is put stuff in a queue and never read anything out of it, right? So it's a really easy experiment. You just make a flow that publishes, right? And you put a limit on the queue and you see what happens. It's going to give you a queue timeout on the publish, and then that's an error, and then your publisher can recover from the error or not. But I mean, the queue's not going to lose the message. You might decide, well, I give up, and right, but it's up to your publisher flow what you want to do with it when it times out. So it's still in RAM. It's not lost.
yes,
But now you have to handle it with an error handler. And that's just like all other, like, so if you're under heavy load and your queue fills up, now you got all these error handlers going off, right? And you have to do capacity planning around that. And that question went on to talk about, I think, memory usage, which, remember, memory usage only matters if you're on a transient queue, if you're in RAM, right? So if you have clustering turned off, I'm thinking Cloud Hub 2, because most of us are going to be on Cloud Hub 2. If you have clustering turned off, you can use a persistent queue instead of a transient queue. And what that means is the messages are going to disk, which is big. You have 8 gigabytes, right? It's not as small as your RAM. So you can have more capacity, right?
yes.
So you could put a max outstanding messages of 100, and then, or you could have more of them. You could put 1,000. So if you're worried about capacity, it's just like a local buffer.
Okay.
But
okay.
it blocks it blocks, and it gives you a queue timeout error.
Perfect. Thank you. And there is another question from Sammy as well. Another question.
The next question does lead into that. So, and it's another good one. Thank you again, Sammy. So the third question is on publish consume. If the requester hit VMQ timeout and the reply arrives a second later, where does that orphaned reply go? Does VM guarantee ordering with listener concurrency above 1 is FIFO lost, and what's the pattern for preserving order per key? Good one.
Well, I haven't seen the behavior. We got a VMQ timeout indeed. So because I was explaining too long, no, we got a VMQ timeout. The question is, does VM guarantee ordering? And we have seen the request timeout several times, but I'm unsure if we got in which demo we have seen it. With the publish, on publish consume, I got it, the VMQ timeout, and I was able to continue with the execution of the flow. The logger in the first flow continue and we reach the logger component. The question is, does the VM guarantee ordering with listener concurrency above 1? I haven't seen this detail. I don't know, Ryan, how is your experience from the architectural?
No, I never. No, if they don't promise it, they don't do it. It's hard to get it to. I mean, you'd have to basically make a load test, right? No, there's no guarantee of ordering. It's not atomic. It's just whatever. The writes won't be interleaved. It'll do one before the other. The messages won't get overlapped, but they are definitely not. Anytime you want guaranteed ordering, you have to make it yourself with max concurrency on the write and max concurrency on the read.
Mm-hmm. 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 Great.
Mm-hmm. That's good. That's good. Another question. This one is from Sangyong, and they're asking, what is the most cost-effective and reliable approach for implementing this asynchronous callback and processing architecture?
Well, according to that, what I present today, the most cost-effective is working with a VM with a VM connector. Okay, so because you don't need to invest in external system, external broker, the setting, the time to configure it, and so on. No? But if you have some requirements, as for example, filtering, delivery messages, robust handling of messages, and so on, then you need to invest in an external broker. Okay. And yes, so in VM, we have seen the VM publish operator guarantee asynchronous communication, okay? So if there is no budget and you need a lightweight solution, then go for a VM connector. With the behavior fire and forget, you can trigger the execution of another flow and finish with your parent flow execution. And yes, this is the most cost-effective solution here.
That makes sense. Thank you, Tricia, for answering that. Sammy is coming back with another one, and Sammy said, thank you. So then what happens? So this is another question. So then what happens if I publish a streamed payload, a large database, result, or file? Persistent queues need serialized content. So does the stream get consumed or does it fail?
Yeah, that's another good experiment one, because you can use a file or something, right? And again, you don't need a reader on your queue. I believe, and this is why I would want to do an experiment. I believe the max outstanding messages blocks the beginning of the write, so it doesn't begin reading the stream at all. So your stream won't have been consumed yet, and then you get to your error handler and you could still read it. Now, Mule repeatable streams means even if it did have a cursor, you would still be able to reliably read the stream as long as you didn't turn it to like a non-persistent queue. But yeah, you haven't already eaten your RAM before finding out that the queue is full. I think that was what the motivation of the question was, right? Because if I have this giant file and I go try to write it to the queue and it won't fit, that would be a bad situation to be in. So I don't think it's consumed until it writes. Now, I would want to do an experiment. A lot of times in my architecture class, I get a question like that where I haven't found, and I guess, Sammy, you probably read the VM connector documentation and been disappointed because these sorts of things are not
Cover, yes.
rigorously defined. So I have to fall back on experimental evidence. And so that's what I do. I just do an experiment.
I will do the experiment as well. It's a very good one to see it live.
Right.
Yes.
And if anybody, if you do the experiment, put it in the comments.
Yes.
Drop it in the comments. Let us know if you're watching this later. Yeah, that's a good one. I'd like to see that. Thank you, Sammy, for that other question. Tony has a question. Thank you, Tony, for your question. So Tony's asking, how does one effectively migrate an on-premise Mule 4 application that uses the Mule 4 VM connector to a Cloud Hub 2 environment?
Yes, and it was more or less the comment from Ryan.
Yeah.
With the settings. There are some settings that you need to take care. Yes, so this is a very important information in Cloud Hub 2.0. You are not able to see anything about queues at all, as Ryan said. And yes, you need to check the boxes with clustering. It was one of it, very important, the configuration. And yes, so Ryan, any other tip here?
I mean, you got to watch out for domains. Hi, Tony. Yeah, Tony and I have talked about this in person once. A couple of years ago, I was at where I got this doll. But the on-prem, you can, and I don't do it very often, but you can share VM queues between apps in a domain. And so some on-prem customers get used to that, and then that's gone. You got to go to Anypoint MQ if you want to go to cloud. You can't have anything like that. So that's a good one to watch out for. If you have been using domains to share VM queues between apps, you have to no longer do that. What else? On-prem is nice and resource. You have a lot of resources. You have a lot of RAM. You have a lot of disk. You move to Cloud Hub, you don't. When you're in Cloud Hub, if you're on clustering, all the queues are in RAM. Even if you make them in the little setting, you say persistent, it doesn't matter. MuleSoft ignores you and puts it in RAM anyway. So you have to watch out how big your VM messages are. If you're on-prem, it's easy to get used to having a lot of RAM and disk and right. So that's gone when you get in Cloud Hub. So you might have to actually break your messages into littler pieces or something. I mean, you have to think about that. What else to think about to go from on-prem to Cloud Hub VMs? I think you can use those settings that Tricia was really good about showing us. Like you can use that max out sending messages setting in back pressure. It might make your application run a little slower, but if you used to have 16 gigs of RAM and now you have half a gig, you could just do less at once, right? Just have a little bit in there at the time and block on the writes with a long timeout, and then don't read from the stream, and now it'll not fill your machine up. I have gotten a lot of pretty big stuff to run on Cloud Hub 0.1. You can do it. It just might take application changes, which I know anybody migrating from on-prem to the cloud would rather not have to recode all their applications. I feel your pain. But yeah. There's a nice little table, Tony. He said, so the next question says, how much disk space is available in Cloud Hub 2? So on the little tiny fractional workers, which all of us, or replicas, which all of us want, it's 8 gigabytes is what you get, which is, it's not nothing. Yeah.
Great. Yes.
Mm-hmm. It's not nothing, but when you're on-prem and you have one of these little guys for $200 that has a terabyte, it's like you feel like 8 gigs you feel pretty cramped in 8 gigabytes. It's like moving out of a house into an apartment. It's like, oh boy. Yeah.
Totally understand. Yep, that's good. Thank you for answering that, Ryan. Sang-Yong has another question asking, how can I implement effective persistent transaction logging in an asynchronous process, and what are the best use cases for it?
Well, according to my understanding, when you are working with the deployments, okay, you have, so here we have two topics here. So first of all, the VM queue types, persistent queues, okay, and then the logging component. And for the logging component, we all know that we can work with loggers, okay, and the loggers can be configured with different logging levels, okay? And according to the information that you would like to log, so what we have seen, let me go back to my Anypoint Studio. And if we go to the logger component, so here I am, you see that there is per default an info level log. And this information is the one, this is the place where you can select debug, error, trace, warning, okay? So we, as I said, we are working here with two topics. The first one, the type of queue persistent, working with the VM connector, VM module, and the operators. And the other one is the logging, the option to log information as soon as we deploy the application, okay? Now, we know already, we just learned that with a persistent queue, our information in the queue will survive a restart, a crash, a system crash, okay? Now, you need to select what would you like to log after a deployment, okay? But still, the question is, in the deployment, so you are seeing the different options of logging, okay? But as I said, these are two different things. VM queue type persistent and logging information with, we just have debug, error, trace, and warning, okay? So two different things, okay? Now, your question is, how can I implement effective persistent transaction logging, okay, in a asynchronous process? Well, you have the possibility to always log information and asynchronous process. So I do believe this is a mixture from different concepts, your question. So synchronous communication is support through our publish operator, okay? And if you would like to log data, you need to set up loggers and configure the different log levels so that as soon as you deploy, you are able to see this information. And yes, and if you would like the queue data to persist after a system crash, you need to work with a persistent queue. So I hope I organize a bit the three topics that you mentioned here, Senor.
I think you covered it. Yeah, you covered that.
Yeah.
Thank you for covering that. Thank you, Ryan, for being here. I see you got to drop pretty soon. And I'm seeing the questions slowing down. Tricia, I really appreciate you answering all these and handling this. You have one more thing that I've asked you to show. So Tricia had, well, I'll let you go. I'll share my experience with it. Go ahead.
Thank you so much. So first of all, I would like to say that I would love to connect with you. And here you have the QR code to my homepage to see what I offer. And yes, I'm available also on LinkedIn. Here you have also the QR code. I will be really, really happy to be in contact with you all. And yes, additionally to this, I would like you to be part of the story. Would you like to be part of my book launching? In my book, I am speaking about how you can recover after a corporate restructuring or a layoff, how you can recover your identity. So how to get back from a corporate identity to an individual identity. And my book name is Illuminating the Path. Additionally, to be a technologist, I love also to help people in such a cases. I am a happiness coach, and I just wrote my own experience after being laid off about how you can recover your identity. And if you say, yes, I want to read it, I want to see it, then please scan this QR code, and I would love you to join me. If you do so, you will get the first chapter of the book free of charge, and you will be part of you will be informed as soon as we launch the book. So, and get a special offers and be part of the community. It will be fantastic. Then thank you so much for being here. It has been a big pleasure. Thank you so much. And I wish you fun with your endeavors in MuleSoft. And if you have any question, I'm here to support you. And thank you so much, RJ and Integration Quest, for the invitation. I enjoy a lot.
Absolutely.
Thank you so much.
Thank you so much for coming out. Thank you. We really appreciate it. And I just wanted to say, I did read that chapter 1, everybody. So I do recommend it. Tricia has written this based on experience, and it's very helpful, enlightening. And it's just a really, what I got out of chapter 1 so far is just it's a great way to find peace in your life. Okay. And I'm looking forward to the rest of it. I really am. I'm going to take this part off here because you've already answered so many questions. We don't need to do that anymore. I'm just going to throw out here real quick one final thing before we turn this off is basically just what's happening next week. I'm just wanted to pop this up here really quick. So we're picking back up the data relay part 6 of 6 now. So the data relay, it was going for a while there. We needed to take a break for a few weeks, and we're back to it. Gigi Chan's coming in and going to go over Slack integration with MuleSoft. So I'd love to see everybody there. What a great thank you so much, Tricia. I mean, words can't express how thankful I am for you coming out, and you did such a great job. Everything was really well organized, really well structured, and that was awesome. I'm going to stop the recording because we're an hour and 32 minutes. I don't know of a time that I've ever hosted one of these, and we reached an hour and 32 minutes and no editing.